Welcome to the class. The first thing you need to do is you need to go to the website aplusstudents.com and you need to log in on the website. Then what you need to do is, since we are having a maths class right now, you need to select math. After selecting maths, you need to go to your grade level. Your grade is grade 8. Okay, select your grade, and after this, you go to the topic. We would be doing data and graphs today. The data and the graph is, okay, data and graphs. We go to the topic, data and graphs. This is the topic, data and graph. Once you're in this, you need to look for lesson number 5. The lesson number of 5 is, the name of the lesson is create line graphs. Okay. Okay. So once you are in the topic, we're in the lesson number 5. We'll start off with the lesson. Okay. So the question says, I'll put down the screenshot of the question so that it's easier for us to understand. The question says that, okay. So this is the question that we have. When we're reading the question, what we need to do is, first time we just read the question. And the second time, what we do is, we mark what is important. To figure out how many vacation days he had left, right? How many vacation days were left? So to use, right, we have to find this. Mario looked over his old calendars to figure out how many days of vacation he had taken each year. So what he is doing is, in order to find the number of days he can avail for the vacations, he is looking at how much he is availed and how many are left. So a grid is given to us, and which represents vacation days taken by Mario. In year 2005, he took 25 days as vacation, 20 days as vacation, 2008, 20 days, 2011, 10 days, and 2014, he did 15 days, right? Okay. So what we need to do is fill in the graph. There's a graph given to us. We need to fill in the graph, and let's see. Okay. This is given to us. A copy of the graph is given to us. Let's paste the graph. Fill in the rest of the graph the same way, right? So what exactly is happening over here is, we see in 2005, in the year 2005, he took 20 vacations days, right? In the year 2008, he took another 20 days. We mark 20 over here because on the y-axis, this is the y-axis, we have vacation days on the y-axis. Okay. On the x-axis, we have the years. So in 2011, he took 10 days off. We'd say 2011, and we go up where we see 10, we mark this point. Then 2014, he did 15 days off, 2014, and this is 15 days off. Okay, so Once we have the graph with us, right, what we need to do is, it's already done over here. I'm just trying to explain. We join the points together. This 2 points are joined, the points are joined, and the pattern of the graph is there. So the line graph is drawn for us. Okay. So from this graph, we can say that in 2005, he did 20 days. 2008, again, he did 20 days. That's why it's a straight line, right? But in 2011, he did lesser number of days. That was 10 days. That's why the line is slant, decreasing downwards. In 2014, he increased the number of days from 10 to 15. That means the line is increasing. So this is a grid. This is a graph showing the data, how many days of vacations were taken by Mario. Okay, the, let's try another question. Let's look at another question. Okay, uh, let's do a screenshot and let's continue with the question. I'll just copy this so that we have the question with us. Okay. If this is the question that is given to us, okay. The question says, a research group noted the amount of meat consumed per capita each decade. Decade means 10 years. Okay. The amount of meat consumption. Okay. So in this question, what we need to do is we need to see how much wheat was consumed. Okay. Let's go back and see. Okay. So in the year 1930, 50 kilograms of meat was consumed. So when we go to the graph, we go to 1930. Can we say 50 kilograms? Because on the y-axis, it is kilograms, the weight, and x-axis, x is the horizontal axis, and we are labeling the years on that. In 1940, he did 50 again. There were 50 kilograms of per capita, right? So in 1940, there was again 50 kilograms. In 1950, how many kilograms again? In 1950, it is again another 50. Okay. In 1960, after 10 years, the meat consumption increased from 50, it became 60 kilograms. In 1970, the meat consumption again increased. It went from 60 kilograms, it went to 70 kilograms. So now what we need to do is we need to join the points to see the pattern. Okay. From 1930 to 1940, it was same 50 kilograms and 50 kilograms. But from 1940 to 1950, it's still the same 50 kilograms. But what happens from 1950 to 1960, the consumption has increased. So we join these 2 points together. Okay. And the next one, in the last one, what we can say is from 1960 to 1970, the consumption again increased and the consumption is now 70 kg, right? So from this graph, what we can study is that the consumption from 1930 to 1950 was constant. It was 50 kilograms per capita, right? Per meat consumed per capita. But after 1950, more people started eating meat and the demand increases, right? So it's increasing in the quantity. There's an increase in the quantity of consumption. Okay. Let's try another question. Let's go back to the website. Let's go to the lesson. Okay. The next one we have is Uh, let's see. Okay. The next question we have is, let's copy this and let's draw this. Okay. A pair of Lawrence High School. Okay. It says, I'll just copy it so that we can continue with the question. Okay. Okay. The next question is this. A pair of Lawrence High School hockey fans. It's talking about hockey fans counted the number of games won by the school each year. So they're talking about the games that are being won. Okay. So in the year 2000, it's on the grid, it says hockey games won by Lawrence High. The year 2002, how many games were there? There were 8 games won, right? In 2004, there were 4 games which were won. 2006, 2 games were won. And 2008, another 2 games were won. So now what we can do is we can look at the values, because on the horizontal, on the x-axis, we have the years. On the vertical axis, the y-axis, we have the number of games, right? So in 2002, in year 2002, we can say 8 games were won. In 2004, there were 4 games which were won. So we look on the y-axis, 2004 on the x-axis and 4 on the y-axis. Okay. In 2006, 2 games were won. And 2008, again, 2 games were won. So when we'll join the points together, right? So we will create a graph over here, and the graph will show us what was how did this team perform, their performance over the years, right? From 2002 to 2008, we get to see the performance. So what we can say is in 2002, the team was winning a lot of games. But in the next 2 years, from 2002 to 2004, the games, the winning game streak reduced to half. From 8 games, they only won 4 games. In the next 2 years after 2004 till 2006, they again lost a lot of games and they just won 2 games. They did the streak went half again. But after 2006 to 2008, it's constant. They're just winning 2 games. So by looking at the grid, if the graph is going downwards, we can say in these circumstances that the performance is going downwards. Okay. So just by looking, so if the question says what was the best performance out of these 8 years or from 2006 years, so we would say 2002 was the best performance. What was the least? What is the time duration where they performed the least? That would be from 2006 and to 2008. So we can assess the graph, we can read the graph by plotting the values, and after looking at the graph, we can tell what was a pattern. We can find the pattern of different scenarios over here. Okay, let's move on to the next question. Let's see. Okay, the question says, I'll just copy the question. A meteorologist, they're talking about a meteorologist. Okay, let's see what happens over here. Okay, let's paste the question. Okay, the question is here. The question says that, okay, I'll just move this up a little so that it's on our screen. Okay, good enough. A meteorologist kept track on the average temperature. They're talking about average temperature in Minneapolis for a full year. Use the data in the table to complete the line graph below. Okay. The average temperature, this says average temperature, right? So the average temperature in February was 10 degrees Fahrenheit, right? In April, it was 20 degrees Fahrenheit. So let's start with the first value. In February, it was 10 degrees Fahrenheit because the temperature is on the y-axis. The number of years are on the x-axis. Then in April, the average temperature was 20 degrees Fahrenheit. In June, the temperature was 30 degrees Fahrenheit. August, the average temperature was 50. We look at 50 over here and we plot it over here with the August over here. And October, it was 60. October would be 60. So when we join the points together, we will see the pattern of the temperature change. Since it's going towards up in the upward direction, right? That means the temperature is increasing. That means it's getting more hot over there. So, and we can also see the difference, which month, average temperature in which month was the highest, right? Increase was the highest. What we can see even from the grid that from June and August, right? June was 30 and August was 50. That means it had a jump of 20 degrees Fahrenheit. Similarly over here, when we look at the graph over here, we can see that this graph is moving between two boxes vertically. See, I'll just highlight it over here. The change in these boxes is 2 over here. The change in the other ones would be lesser. So let's see what is the lesser change. They had a smaller change, right? One box of the height over here, more height. That means more temperature change in that particular month. Okay, so what we can use is we can use these diagrams to interpret and understand data. These are usually used for that particular reason. Let's try one more question and let's see what else can be there. Okay, if we pick up this question and let's try the question. Okay, the next question would say, okay, this is the next question. The Sam parents kept track of the number of times the attendance office called to report that he had been late to school. Sam had been late to school and the school calls the parents, right? Use the data in the table to complete the line graph. In June, he was late 6 times, July once, August 7 times, September 6 times, and October 9 times. So what we need to do is, okay, the first point is plotted for us. February, okay, sorry, is it the same question? Okay. Sorry. Uh, I think this is the wrong graph because it should not be this. Okay, I'll just change the values over here. Okay, we are not talking about the number of days, right? So we'll just simply change these numbers and we'll change these numbers and we change the labelings. Okay, so we need to look at different number of months, right? Okay, the, the heading would be times Sam was late to school, right? Okay, so what we can do is remove this as well. Okay, look at the months. We start off with June. This would be July, August, September, and October. Okay, so in June, he was late for 6 days. In June, 6 days. Okay, after June, it's July. July was only one day he was late at school. July would be one. August was 7. September was 6. And October was this is 7, this is 8, this is 9. We can always extend the graph and we can say this was 8 and this is 9 over here. Okay, so once we have these values, let's plot the graph and let's see what was the pattern. Between June and July, he did a better performance. He went to the school regularly. After July, in July to August, he was late again. Then August to September, there was a decrease by one day because in August he was late by 7 days. In September, he was just late by 6 days. After September, there was an increase again. He was late again at the school. So what we can do is we can see the pattern, how many days in a month he was late to the school. Okay. Are there any questions? If you have any questions, let's discuss those questions. Okay. It's okay. Okay, that's good. Let's move on to the next question. If we would want to do the next question, let's see. Okay. A baseball team. Let's look at what happens with a baseball team. Fans of a Richmond baseball team, we are talking about the Richmond baseball teams. We copy them. Let's copy the question and let's try the question. Okay. If this is the question given to us, the fans of the Richmond baseball team compared the number of games won by the team, right? So each year, in 2005, they won 30 games. So we can say that in 2005, they won 30 games because games are on the y-axis and x is the number of years. In 2008, they won 30 games again. Okay, we make a dot at the points. In 2011, they won 20 games, and 2014 they won same number of games, 20 games again, right? So what we do is we join the points together. That means from 2005 to 2006, they had a consistent performance, right? But what happened after 2008 was that their performance went down. They were winning 30 games. Now they won only 20 games in that duration, right? But after 2011, what happened was, even though their performance was lesser compared to the 2008, but for the next year, they were consistent. From 2011 to 2014, their performance was consistent and they did 30 games, 20 games over here also, right? In general, the performance went down, but there were two phases where they were consistent. Okay, this is how we can read the graph and we can find values from here. Like we can predict like what would be the pattern next year. These are used for predictions and arrangement of the data, the line graphs. Let's see, a vendor who sells, let's see. Okay, the question says, I'll just paste the question here so that we would be able to see. Okay. A vendor who sold bread at farmer's market counted the number of leftover. Okay. He's selling bread and they have leftovers loaves at the end of the day. On a Sunday, he has 80 loaves which are left. Okay. And so on. We can go through this. Similarly, Monday, it would be 70 loaves. Tuesday, 80, and Wednesday, again, 80 loaves. Acha. The question says, look at the first line of the table. The first data point is for Sunday. They have labeled the first data point. On a Sunday, this was 80. They've already labeled. So we need to complete the diagram, okay? So what we can do is, on a Monday, it was Sunday, there were 80 loaves, and on Monday it were 70. So we look at Monday and we go to 70 and we mark at the intersection of Monday and 70. Tuesday, again 80. Wednesday, again 80. So when we join these points together, we will look at a pattern of not only how many loaves were left, right? We will also look at the pattern of on which day there were maximum sales. Having a leftover, more leftover means less sales, but less leftover would mean more sales. That means on a Monday, there was comparative more sales, a little more sales, 10 more sales, right? If we look at the values, it would be like on Sunday they had 80 loaves, Monday they sold 10 extra loaves. So they only had 70 loaves, right? So that means the question can be changed and modified with the data. So we can use the data in multiple ways. Okay, let's go to the next question. Okay, let's try the financial aid officer at a university. Let's see. We post this and then we'll study the question. Okay. The financial aid officer at the Dyer University produced an internal report. Okay. They have an internal report. Let's mark this on the number of students receiving scholarships. In 2001, there were 40 students who were receiving scholarships. Okay, so they marked 2001, 40 students. Similarly, 2005, that would be 70 students. 2009, that would be only 20 students. Okay, and 2013, there are only, okay, 10 students. So when we join these points together, we will find the pattern of scholarships at this college, right? At this university, what is happening? Okay, let's see now. The financial aid office at Dyer University produced an internal report. Their report was that these are the numbers of scholarships. So the number of scholarships, if the question would say that in from 2001 to 2005, they were giving a lot of scholarships. But after 2005 to 2009, they abruptly changed the number of scholarships. From 70, they brought it down to 20. 50 students were taken off scholarships, right? Previously, they might would have offered in 2005 70 scholarships, but in 2009, they just offered 20 scholarships. But from 2009 to 2010, they again reduced it by half because in 2009 they were giving 20. In 2013, they're just giving 10 scholarships. So they are reducing the number of scholarships. We can look at this pattern from here. Okay. Let's move on to the next question. Let's see what we can do. Okay, let's try another question. The questions that we have is her. Okay, I'll just copy this so that meanwhile, a movie fan tracked winners of the movies. Okay, these could be used in a lot of scenarios, even in everyday life, like by the teachers, who is performing well, which subjects performed best in these years, what is the pattern, how are the students getting the marks for this difficult test. This would be the criteria. So these things are used in everyday life. Okay, not only in offices, but we usually do not draw these graphs. But in general life, we are assessing information, like, okay, this phone was this cost there, and now this is the price, or this is the price of the shoe, and after the discounts this would be. So everything where we have a comparison, price against a value, we can do these. Okay, so let's see. uh, Okay. A movie fan track the ages of best actresses award winners. Okay. Ages of award winners. In 1981, the best actress was 30 years old. 1981, she was 30 years old. 82, a 70-year-old actress won. 83, again a 30-year-old one. And in 84, a 50-year-old one. Right? So when we join these points together, so what we can say is it's a mix and match. Sometimes older people are winning, and sometimes the younger people are winning also, right? So when we compare it, so the information can be, the judges are not biased, right? Who are giving the award, like they are giving based on acting. They don't have a particular mindset that they would give it to the younger or they would give it to the older. Whoever performs best would get the award. So we can infer a lot of things from this. Okay, let's try a few questions from the test. Let's do some questions from the test. On the right hand top corner, on the right hand top corner of your page of the website, you will be able to find the icon for test, right? Just click on that and you'll be able to find it. Okay, I'm also moving there. Let's do a few questions from the test, because in the test they give us multiple options and answers. So let's see what can be our answers. Okay. Okay, if the question is given as, I'll just copy the question. Question number one, it says this is given to us, this information. I'll just copy the question. Okay. I'll put down the heading of test so that you people know that we are trying the questions from the test. Okay. Okay. These were the given info. This is the given information. A research group noted the amount of meat consumed per capita each decade, right? Use the data in the table to complete the line graph below. Okay. So now they have given us multiple options and we need to choose between those two options, that which option is the correct option. Okay, it's a MCQ. An MCQ is a multiple choice question where they have given you more than one choice and you have to pick the correct option. Okay, so these are the two options over here for us. Okay, let's see which option is the correct option. Then we'll go to the website and we would attempt the question on the website, right? So that there are total 10 questions. They would be easy. So we do a few here, the remaining you do at home. Okay. And if you have any problem regarding the topic, you can always go to the recorded sessions, and you can have a look over there. Okay. Okay. In 1930, it was 50. 1930, 50 agreed. 1930, 10. That is wrong, right? 1970, this is right, but this is right. But even if one of the points is incorrect, that means it is incorrect. That means our correct answer is option B. So let's click on option B and let's find the correct answer. Okay. Yeah, that is the correct option. Okay. Let's try another question. We're done with the first question. Let's try one more. Okay. The next question says that there are some emails. Let's see. We copy this, paste this. Okay. Okay, question number 2. The question number 2 says, Lauren kept a tally of the number of emails she received each day for a week. So we are looking at the number of emails, right? This is the keyword for us. Day and emails. That means Monday, use the data in the graph to complete the information. In Monday, you had 2 emails, Tuesday 2, Wednesday 4, Thursday 1, and Friday 4. Let's see which of the graph is the correct answer. Okay, so we go over here. We try to bring those 2 options for us, and then we'll compare which option was the correct option. Okay, so if these were the 2 options that were given to us, let's see which values would be correct. See, we can say that Monday has to be 2. Here Monday is 2, but here Monday is 5. So if even the initial value is wrong, that means this is wrong and this option is the correct option. So let's go to the question and let's click on this. Okay, if it's a correct option, it would show a tick and it would move on to the next question. Okay, we have another question which says that, one minute please, let me copy paste so that we have a clear picture of the question. And the question says that it's about a hockey fans. Okay, hockey game fans. Let's read the question. The question says, this is the question. Okay, a pair of Lawrence High School hockey fans counted the number of games won by the school each year. Okay. Okay. We have the tables in this case. We will just look at the tables and see which of those tables are correct. Okay. So if we have these 2 tables over here, let's see which 2 tables are correct. So we know that in 2002, they won 8 games. It shows 8, but this shows 2 games. Okay, that means the first option is the correct option. The second option is the incorrect option. Just by looking the plotting of the values, we can tell which option is correct and we can say which option is incorrect. Okay. Let's do another question. And okay, we have a graph over here. Let's remove the graph. Okay. And let's fans of Richmond baseball team. Okay. Let's say they are again talking about winning streaks. Okay. They won these many games. And let's see which diagram would be the best representation of the information that has been provided to us. Okay, if we have this information, fans of a Richmond baseball team compare the number of games won by the team each year. So they are comparing the number of games won. And these are the two possible options we have. Okay. In 2005, they won 30 games, right? So when it says 30 games, the first value we need to see is, where is 30? It's 30 over here. That's fine. But it's 20 over here. That's incorrect. So we directly know, we don't even have to see, this 30 was also fine. Then 20 is fine. And this 20 is fine, right? All 4 points are plotted properly. But in the next case, 2008, 30 is fine. 20 is fine, but this is not 40, right? The two of the points are plotted incorrectly. Even if one of the points is plotted incorrectly, then the answer would be incorrect. And the correct answer in this case is the first graph we have. Okay, so the first one would be a correct answer. Okay. We're already done with the 5 questions. You're just left with a few more questions. Please do try those questions so that you would yourself know whether you understood the topic or not. Okay, it's it's for your own betterment. So you need to do those questions, and if there is any problem, you can always go back and see the explanation. Okay, the question says that, okay, a meteorologist kept track of the average temperature in Minneapolis for a full year. Use the data in the time row to draw. We don't have to draw. The answers are given to us. Let's see what the possible answers are. So in this case, we just need to compare. We just need to compare the first two, right? We just compare even the first value we can compare and we can find the answer. In February, it was 10 degrees Fahrenheit. February is 10, agreed. February is missing in this case. February is missing, right? Okay. April is 20. April is 50. That is incorrect. This is correct. So even if there is one incorrect value, that means the graph is wrong and the second graph is a correct graph for us. Okay. So once we click on this graph, the second graph is correct for us. Okay. Let's try another question. The question says that, just a moment, please. Let's pick up the question and let's try to find this. And one more thing, if you have some problems with this question, there are also tutorials available on the test and there is also hint available, right? So if you have any problems, just go for the hint, look for the hint so that you'd be able to understand. They will explain you the question. Okay. And the given answer for these two is, these are the given answers, right? I'll just copy them over here so that we have a better picture of what exactly are being asked about. Okay, to figure out how many vacations days had he had left to use, Mario looked over his old calendars to figure out how many days of vacation he had used each year, taken or used. In 2005, he used 20 days. So let's see. Oh, the first one is blank, totally blank, right? So that means this is not possible. Let's confirm this. This is 20, agreed. Then 20, agreed. Then 10, let's see if it's 10. Yes, it is 10, agreed. And this is 15. Yes, this is 15. That means the second option is the correct option because the first one is a total blank graph, okay? I would expect you people to practice the remaining, I think 4 questions are left. You give those 4 questions a try and best of luck. Okay, take care. Have a nice day. Take care. Bye.